Hi friends, good morning. Welcome to this lecture on regular expressions in NLP. We are going to discuss how to use regular expressions for text search. So regular expression is basically a language for describing a pattern uh, to support the text search, uh, specifically for information retrieval, text analysis, or information extraction, speech recognition, and similar text mining task or text analytics task. So we also use this mechanism in phonology analysis and morphological analysis. These are case sensitive language. For example, the lowercase s is different from the uppercase, and these are treated as different. And the lowercase s matches small s in any of the sentence, uh, but not an uppercase letter. Yes. So this means that the pattern, for example, willpower will match only the willpower containing lowercase letters, but it will not match the uh, word willpower starting with uppercase letter W. We can solve this problem using the square bracket. We'll see how to do that. So we can use a string of letters, or we can use digits to be used within the square bracket. So it specifies a distinction of characters or digits to be matched. So for example, here we have the word regular expression willpower specified inside this slash, and this will match the corresponding word willpower in this sentence. So in the second example, A is a pattern to be matched. So A is present in this word Mary. So this will match. And the third example, exclamation mark is present at the end of this Happy New Year. So this will be matched. Now let us discuss example for distinction operator. So this operator is used to specify either or pattern. So for example, if you want to have a match that combines either lowercase letter or uppercase letter, then we can use this operator. So we can specify a string of characters inside the square bracket. For example, here we have specified lowercase w, uppercase w. That means that any word containing lowercase w or uppercase w will be matched uh, in the search process. So in the second example, A, B, C is given inside a square bracket. That means A, B, or C will be considered as a uh, pattern for matching. So in this particular sentence, the word soda contains a letter A that will be matched. Then in the next example, we have digits 1, 2, 3, and so on. So this specifies that any digit present in this square bracket will be matched. For example, 7 is present in this sentence. So not to use this, we can also use a pipe symbol to support the search mechanism to specify either or not either or pattern of search pattern. We can use this pipe symbol. Since we cannot use a square bracket to search for cat or dog, we need a distinction operator. It is denoted by this pipe symbol. So this will match either the word cat or dog in the sentence. So the next is operator precedence. We need to consider the precedence of operators while uh, formulating an expression, regular expression. For example, here we have some examples operators. Parenthesis takes highest precedence, then counters, uh, these operators, multiplication operator, and then plus, question mark, basis. These are all taking the next level precedence. Then sequences. This anger symbol, caret symbol takes the next level precedence. Dollar symbol takes the next level precedence, and then the disjunction operator has the lowest precedence in this example. So these are the list of operators for regular expressions. So based on the precedence, we can use. So if we use parenthesis, that will be processed first. So sometimes the patterns may be ambiguous. So we'll consider this example A to Z star. So this specifies that this will match to the pattern against the text. Example, we'll consider this sentence once upon a time. So in this example, we have a matching pattern A to Z. So this will consider zero or more letters in an expression that will be matched to the given input string. So this specifies that zero or more letters in a string. So in this example, the first word once has so single letter O at the first. So this will be matched, or ON on, or ONC, or ONCE, all these letters. So this will specify zero or more letters while matching. In these cases, regular expressions match the largest string. We can also follow a greedy approach or non-greedy approach to do this matching. So in greedy approach, this will expand the search to cover as many as letters possible. But non-greedy, we can restrict this search process using another operator called question mark qualifier. So we can combine this with the star operator, clean operator. So clean star in combination with the question mark specifies that it matches as little text as possible, then plus this question mark operator, and clean plus matches to the characters in the string as little character as possible. The next example, we are going to consider searching for information about pet fish for question David, named David. So we'll see how to specify both Gubby and Gubbies. So here in this example, we cannot simply give like this Gubby and pipe symbol IES, because it would match only the strings Gubby and IES. So this precedence is because sequence like Gubby takes precedence over the pipe symbol. So in order to address this, we can make the disjunction operator apply only to a specific pattern. So we can use parenthesis for this. For example, here we are enclosing this y and ies separated by pipe symbol inside the parenthesis. So this takes precedence now. When we enclose a pattern like this in parenthesis, it acts like a single character for the search process. So this would specify that we mean the disjunction only to apply to the suffixes y and ies. Next, we can also use range of characters or letters while formulating a search pattern. For example, we have a well-defined sequence associated with the set of characters here, A to Z. All these are uppercase letters. So wherever we have uppercase letters in the sentence, those uppercase letters will be used for matching. In the second example, we have digits 0 to 9. So a single digit, for example, in the sentence chapter 1, so 1 is the digit, so it will be used for matching. Next, we can also use negation operator to specify a single character that can be excluded. So this should be used at the beginning of any pattern that you formulate. For example, when you start with the opening square bracket to specify a pattern, then at the beginning itself you should specify this operator, caret operator, and then give the character that you don't want to match to the pattern. So this is one example for that. In this example, we can see we don't want any uppercase letter while searching, so it won't match A to Z uppercase letters. That's why we start with a caret symbol. And similarly, in the next example, we don't want either yes or lowercase s or uppercase s in the search process. That's why we use like this. Then the next example, we have used caret symbol at the beginning and then dot operator. This specifies that we have to search all the characters or this except this period operator. In the next example, caret operator is used at the end, so that means that this will consider either E or the caret operator. For example, in this sentence, so this will this will match to this caret operator also. Then the next example, here B, so it is used at the middle, caret operator is used at the middle. So this specifies that the pattern here B is to be searched. Now we will discuss about clean operator. Cleaning star specifies that the search is directed to match 0 or more occurrences of the characters immediately following the character that you specify or the regular expression that you give. So for example, A star means any string of 0 or more A's. So this will match either single A or these 6 A's or more than that. But it will also match the empty string that you have to remember. At the start it will match the empty string. So here the regular expression for matching one or more has to be specified like this. If you want to match one or more, then give one A as letter, then A star has to be given. In the next example, a little bit complex pattern is to be used. For example, A, B whole star. This specifies that 0 or more A's or B's can be used in a search process. So this will match the strings all A's or all B's or combination of A's and B's as well as empty string. So if you want to specify multiple digits, we can also extend this 0 to 9, specify in the square bracket. So the regular expression for a single digit will be like this, and for multiple digits we'll use star 0 to 9, the whole star. And then cleaning plus specifies one or more occurrences of the character or digits following a particular character or regular expression. For example, 0 to 9 plus specifies that you are searching for a sequence of digits. For example, for the sheep language, we can have BAA star, so multiple A's, here BAA plus. That means we can use one or more, it will match one or more pattern of this. Here BAA star means 0 or more occurrence of this sheep language. So we have one more important character, period. This can be used as a wildcard expression to match any single character except a character written. For example, in this example, this dot operator specifies that it matches to I in the example begin, and similarly in begin it will specify you. The wildcard is often used together with the cleaning class as well, clean star as well, to specify any string of characters. You can use this. Suppose you want to find any line in which word odd word appears, then to check whether it appears multiple times or twice or not, you can give like this. using dot and clean star operator. The next example uses angles. So in this example, we give angles like character operator at the start of the line, or dollar at the end marker, and slash b to direct the word boundary, and slash capital B to direct non-word boundary. So these are all some of the angles that we use while formulating a regular expression. So these are all the methods that we use in string matching applications, text analysis, or information retrieval. So in the next lecture, we will discuss about morphological analysis. Thank you so much.